guys? Filtering the traffic, right? Filtering is filtering the traffic. If I am blocking the IP, that means I am blocking all types of communication, right? For an example, I have one switch here, and here are some users in my network. Okay, this is my network connected to one switch, and then further switch is connected to router. Switch is connected to router, and let's say router is connected to internet or any other router. R1 and my switch. Okay, this is PC1. Let's say PC1 has one IP address 10.1.1.1. 10.1.1.1. Guys, if this PC is going to ping, let's say 8.8.8.8, what will be source IP address? Let's say PC is going to open the Google page. In the browser, if this PC will type www.google.com, what will happen? It will generate the packet, right? PC can generate any traffic, right? FTP traffic, mail, HTTP, HTTPS, like web traffic, telnet traffic, SSH traffic. It can generate any type of traffic for any device, for any IP address. And my PC is responsible to forward the traffic to gateway. PC will not have route, right? PC don't know where is the internet. Am I right? Does your PC know how to route the traffic to internet? No. Who knows that? My router knows that. Gateway knows that. Gateway has routes for the internet.
Yes.
Right? Means my router will have route in their routing table. Router maintain routing table, you know this. And router will forward traffic on the basis of this routing table only. And if route is not there in the routing table, can router forward the traffic, guys? No. Then router cannot forward the traffic. For an example, if default route 0.0.0.0 is there, router can route the traffic towards internet. If default route is not there, router cannot forward the traffic towards internet. Right? Let's say I am pinging 20.1.1.1 from PC number 1. PC 1 can forward the traffic to router, but router will discard it. Because router is going to compare destination IP with routing table, and in the routing table route is not there. Right? That's why we are running routing protocol or a static routing, so that my router can learn the routes dynamically. Let's say router 1 is connected to any another router, and from that router it is learning this prefix 20.1.1.0/24. And if you are going to filter this network, guys, on router number 1, means all the communication will be filtered. Now user cannot send any data to 20 network. Right? So there are two types of filtering: control plane filtering and data plane filtering. Control plane and data plane filtering. Data plane filtering means filtering the user traffic. As you said, that applying access list on the interface of router, that is for data plane filtering, right? When router will receive the user data on the interface, at that time it will block the traffic, right? In that case, maybe I am blocking the HTTP, but I am allowing the FTP. So router will have route in the routing table. Router will only filter the HTTP data. It will not filter the FTP data or any other types of traffic. Yes, na?
Yes.
Right? So data plane filtering means filtering the user data, the actual data. And control plane filtering means control plane filtering happen at routing level. Means you are filtering the route from the routing table. Guys, even ACL, let's say access control list is applied in the outgoing direction. Here ACL is applied. When router will check the ACL? After the routing table, if router has route, then only it is going to forward it from here, from the outgoing interface, and that time it will see, okay, ACL is configured, let me check. If traffic is not allowed, it will filter. But if route is not there, then router will drop the traffic even on the ingress interface, on the receiving interface. So in the route filtering, we are going to learn which type of filtering. Control plane filtering. We are filtering the route, right? Means all traffic will be blocked. And which route? Unwanted route. Which route? Unwanted route. Unwanted route means?
Which we don't want to advertise or receive.
Unwanted means which are not required.
Yes.
Which are not required. For an example, as I told you, router 1 is connected to router 2. Let's say router 2 is advertising 1000 number of prefixes to R1. Router 2 is advertising 1000 prefixes to R1 through any protocol EIGRP. EIGRP is running between R1 and R2 and it is advertising 1000 prefixes. 1000 prefixes. And router 1 never forward traffic in these 1000 prefixes. So that these are unwanted prefixes for R1. It is not sure that this is unwanted for R2 also. Maybe user on R2 are forwarding traffic in this network, but R1 is not forwarding. Or maybe R1 need 50 subnet out of this 1000 prefixes. That means 950 are unwanted. So you need to filter that unwanted prefix. You don't need to filter the entire routing table, and you cannot filter it. If you will filter the entire routing table, there will be issue, right? So we are going to perform filtering at routing level, right? We are filtering the route from the routing table of router, unwanted prefix from the routing table of router. And later, again, we will have access control list. Access list is topic of our syllabus. Later, we will learn the ACL in detail. At that time, you will see how we are filtering the user data. Maybe PC1 should have limited access of internet. In that case, I can configure the ACL, but limited access. So you cannot filter the route. You need to allow few services only. Right? So with the help of route filtering, we can tell to router which prefix router need to learn, router need to install in their routing table, which prefix it need to advertise to their neighbor, which prefix it need to accept to their neighbor through any routing protocol. It can be RIP, EIGRP, OSPF, BGP, ISAS, any protocol, doesn't matter. Right? So goal is to control which route get added in the routing table, which route router should install in the routing table. Clear?
सर डेटा प्लेन एक बार रिपीट कर दो ना.
Data plane forwarding happen at the packet forwarding level. When router will be forwarding the user data, at that time it will filter the traffic. So control plane filtering happens at routing level, and data plane filtering happens at forwarding level, at packet forwarding level. After the routing decision, if router has route, so router has make the decision that okay, I'm going to forward it from this interface. At that time, if any filtering is configured to allow or deny the traffic, according to that it will take action. Goal is to control traffic flow based on the policy, based on the security. That is used for security purpose. Even the control plane filtering is also used for security purpose only, because as I told you, these users like PC1 and PC2 should be not allowed to forward the traffic in 20 submit. Better to filter the route on router number 1. Router 1 can then not route the traffic. Any question? To understand this,
Means sir, data plane is like a SEP table.
data plane, no, data plane is not SEP table. Data plane is a user data. Data
It's
plane means
working
I'm
like
talking
a
about
SEP table,
SAP table is the duplicate copy of routing table, bro. If
routing
you are
table, sir.
filtering
Yes,
any
sir.
route from the routing table, automatically from the SAP it will filtered. SAP table is what? SAP table is duplicate copy of routing table in the TCAM,
Yes,
right? So if I am going to filter any route from the routing table, automatically SAP will filter that. Yes, na?
yes, sir.
Okay. Let's begin. Okay. So first topic is here route filtering. Route filtering. Route filtering means you can see means control plane filtering. We are filtering the route. All the traffic will be filtered. Okay, so it is used to filter unwanted prefixes. It is used to filter unwanted prefixes. Right? How we will filter unwanted prefixes? With the help of distribute list. Distribute list. In all the routing protocol, you have distribute list feature. In OSPF, EIGRP, RIP or BGP or ISIS. Everywhere we have distribute list feature, all the routing protocol. So here we can say routing protocols uses distribute list to filter prefixes. It uses distribute list to filter prefixes. How? When distribute list will work, guys? For an example, let's take example of any routing protocol. Let's say EIGRP. So tell me one thing, EIGRP will first build topology table or routing table? First it will build
Okay.
topology table or routing table? Topology table
Yes.
and then routing table, then routing table.
Yes.
And how EIGRP will build the topology table? With the help of update message. Whenever a router will receive the update message, it will store all the prefixes in their topology table, right? So where distribute list will work, let's say this is my router and the router has topology table and this is the routing table of router. So distribute list will work between topology table and routing table. This is topology table and this is routing table. Routing table, right? And your distribute list is working here between topology table to routing table. Let's say in the topology table there is one prefix 10.1.1.0/24 and in the distribute list you have filtered this prefix. So what will happen? Router will not install this prefix in their routing table. Getting my point?
Yes.
Fine. Otherwise, router calculate FD value and it install all the best path in their routing table. Here your distribute list is going to work, right? But in the distribute list, you have to match the traffic, which traffic you want to block, which traffic you want to block. And to match the traffic, we have ACL. And in ACL, we have two types of ACL, standard ACL and extended ACL. Standard ACL and extended ACL. Then you have prefix list. You can use prefix list to match the prefix, or you can use route map. You can use any one to match the prefix, right? For an example, this router R1 is learning 1000 prefixes from router number 2, and router number 1 only send traffic in 100 prefix. 100 subnets are required, rest all are unwanted. So we can filter those all unwanted prefix with the help of distribute list, and we can match the traffic through extended ACL, prefix list, or route map. Now what is distribute list? Distribute list is a tool which is used to filter prefix. But who will tell to distribute list that which prefix need to filter? Maybe ACL, maybe extended ACL, maybe prefix list, maybe route map. Who will tell distribute list that which prefix you need to filter? ACL, prefix list, or route map. Clear? Can I move?
Yes.
Yeah. So first of all, let's see the simplest filtering, simplest route filtering here. I have very simple topology. Two routers are there. Both are directly connected to each other. On router number 2, some subnets are there: 20.1.1.0, 20.1.2.0, 20.1.3.0. First of all, let me configure the scenario, and between router 1 and router 2, I will configure 12 subnet: 12.1.1.0/24.1 on router 1, .2 on router 2, R1, R2. Config T interface F0/0 no cert, IP address 12.1.1.1 255.255.255.0. Exit router EIGRP S number 10 network 12.1.1.0 wildcard mask 0.0.255. Then go to router 2, config T interface F0/0 no cert and IP address 12.1.1.2 255.255.255.0. Exit interface loopback 1 IP address 20.1.1 255.255.255.0. interface loopback 2 IP address 20.1.2.1 255.255.255.0. interface loopback 3 IP address 20.1.3.1 255.255.255.0. router EIGRP S number 10 network 12.1.1.0 0.0.255 and network 20.1.1.0 0.0.255. One more network 20.1.2.0 and 20.1.3.0. Done. So IP EIGRP neighbor, we have EIGRP neighborship, and on router number 1, so IP route EIGRP. You can see all the routes are there. If I am going to send the data, ping 20.1.1, ping is working, right? So IP EIGRP topology table, you can see the topology table, you can see the routing table. Let's say the user connected to R1 only send traffic in 20.1.1.0/24. That means these two are unwanted prefixes over here. This is wanted prefix. This should be installed in the routing table. These two are not required. So unnecessary why router 1 will install these two prefixes if there is no user Who is going to send the traffic in this subnet? In the production, you will have so many prefixes. Lakhs of prefixes can be there in the routing table of router. In that scenario, if you will filter the unwanted prefixes, your performance will enhance, performance will increase. So my main goal is to improve the performance. That's why we are filtering unwanted subnet, right? And guys, simply I can create one access list. Let's say access list number 10, and in this access control list, I am only allowing 20.1.1.0 subnet. That's it. Rest all are deny. Access list number 10 permit 20.1.1.0, and this is the wildcard mask. Rest all the prefixes are deny. And where I will call this distribute list, sorry, access list in the EIGRP, in your routing protocol. Router EIGRP as number 10, and I can call my distribute list here. Distribute list, and now it is asking you the ACL, standard ACL, extended ACL. You can call prefix list, you can call route map, right? There are two types of ACL, number ACL and name ACL. If you have named ACL, you can call to name ACL as well. On the basis of gateway also, we can filter the prefix. Filtering incoming address updates based on gateway. Forget about this gateway option now. Just focus on standard ACL, extended ACL, prefix list and route map. Now here I am going to call access list number 10. And then guys, in which direction? See, in both direction you can perform filtering. In incoming direction as well as in outgoing direction. What I told you, with the help of route filtering, you can control which prefix router should accept, should install in the routing table, which prefix router should advertise to their neighbor. I can perform filtering on router number 2 as well. I can tell to router 2 to not advertise 20.1.2.0 and 3.0 to R1, right? Or I can tell to router 1 that to not accept the prefix from router number 2, means only accept which prefix? 20.1.1.0. So let me say direction in. In means filter incoming service update. Out means filter outgoing update service. So here I am going to use direction in. And after this how you will verify it? So IP protocol. In the so IP protocol, here you can see what it's saying. Incoming update filter list for all the interfaces is 10. 10 is your ACL, and so access list 10. In so access list 10, you can see we are only allowing one subnet, right? Now if I will show you the so IP EIGRP topology table, so IP EIGRP topology table, see which prefix is here guys? Only 20.1.1.0/24. Only this subnet is there, and so IP route EIGRP. Now you can see, right? Earlier 3 subnet were there, now only 1 prefix is there. I can do it on router number 2 as well, right? Go to router EIGRP and remove this. Say no to this distribute list, and again so IP route EIGRP. Wait for some time, soon you will have all the prefixes. So IP route EIGRP. Now you can see all the prefixes are there. I can do same thing on router number 2 also. Access list number 10, and here I can say deny 20.1.2.0 or permit 20.1.1.0. Both are same. Deny this one and then deny 3.0 also. 3.0 and permit 20.1.1.0, right? And then router EIGRP as number 10 distribute list number 10 direction out. On router number 2 direction is going to be out. And now on R1 again EIGRP irreversible flap Wait for some time, it will resynchronize the neighborship. Now you can see EIGRP neighborship is resynchronized. Now if you will check the routing table, again you can see we have same output. So doesn't matter where you are applying the filtering. If you are applying it on router number 1, direction should be in. If you are applying it on router number 2, direction should be out. Any question?
Sir, topology table just see.
Topology table. So IP EIGRP topology.
Okay.
Okay, clear guys? This is the simplest way of route filtering, but this is not sufficient. Why? Because guys, here you can see I don't have even any redundancy. Between router 1 and router 2, I don't have redundancy. If any router or link will goes down, the connectivity will goes down. Definitely you will have multiple path between source and destination in the production. And you need to filter the prefix from any specific source. What is the difference between a standard ACL and extended ACL? In a standard ACL, you can only match source. You can't match destination. Right? So if I want to filter the prefix from any specific site, from any specific path, from any specific source, then standard ACL failed. We can't with the help of standard ACL. We have to use extended ACL because extended ACL allow you to use source and destination. Here we can match source and destination. For an example, this scenario. Now let me close this one. This one is not required. What happened? My entire GNS close. Yesterday we are created one lab. Where is that? Wait a minute. क्या हो गया इस भाई को? बग्स है जीएनएस में क्या? हाँ ये ठीक है. Okay, now here you can see on router number 1, for an example, I want to filter some prefixes from ISP1 or from ISP2, from any specific ISP, from any specific site. Can I do it with the help of a standard ACL? बताओ. Config T, interface F0/0, no cert, IP address 12.1.1.2, 255.255.255.0, exit interface F1/0, no cert, and IP address 24.1.1.2, 255.255.255.0, exit router EIGRP number 10, network 0.0.0, and let me close the ISP1. Go to ISP2, config T, interface F0/0, no cert, IP address 13.1.1.2, 255.255.255.0, interface F1/0, no cert, and IP address 34.1.1.2, 255.255.255.0, exit router EIGRP number 10, network 0.0.0. Let me close ISP2 also. And now R1 and R2. R1, config T, interface F0/0, no cert, IP address 12.1.1, 255.255.255.0, and interface F1/0, no cert, IP address 13.1.1.1, 255.255.255.0, exit interface loopback 1, IP address 10.1.1, 255.255.255.0, exit router EIGRP number 10 and network 0.0.0. I am expecting EIGRP neighborship with both ISP. So IP EIGRP neighbor. Done. Q count is 0 with both the neighbors. Sequence number RTU, SRTT, uptime, hold on time, interface, address, everything you know. On router number 2, config T, interface F0/0, no cert, IP address 24.1.1, 255.255.255.0, interface F1/0, no cert, IP address 34.1.1.1, 255.255.255.0, interface loopback 1, IP address 20.1.1.1, 255.255.255.0, interface loopback 2, IP address 20.1.2.1, interface loopback 3, IP address 20.1.3.1, and then finally router EIGRP number 10 and network 0.0.0. Again here I am neighborship, so IP EIGRP neighbor, done. And so IP route EIGRP through EIGRP, it is learning 10 subnet. Here you can see it is also learning 12 and 13. 12 and 13. Should router 2 learn these two subnet, guys? 12 and 13. 12 subnet is running on WAN link. Router 1 between router 1 and ISP1. 13 subnet is running between router 1 and ISP2. These are unwanted prefix. These are unwanted prefix. Similarly on router number 1. So IP route EIGRP, you can see it is learning 24 and 34. These are unwanted prefix. Right? See, tell me one thing, okay? Guys, only this is my wanted prefix. I only want 20.1.1.0/24 from ISP1. Right now router 1 is performing load balancing for all the remote subnet, our ISP1 and ISP2. But I need this subnet from ISP1 only. Can I configure it through a standard ACL? Yes. In the extended ACL, definitely you can not match source and destination, but you can apply the distribute list on interface. I can apply it on F0/0 or 0/1. If I want to filter everything on F1/0, on F1/0, if I want to filter anything, I can create access list number 10, deny any, let's say. Right, so this access list is going to deny everything. And now router EIGRP as number 10, I can say distribute list number 10 direction in, and then fast Ethernet 1/0. It will only filter the prefix on fast Ethernet 1/0 now, not on both interface. If you will not define the interface, then it is going to filter on all the interfaces. Now you can see EIGRP is resynchronized, and so IP route EIGRP. Now you can see all the prefixes are reachable via ISP1. So you can apply the filtering on any interface as well. Router EIGRP, and now say no to this. Done. Okay. So here, if I want to filter these unwanted prefix, so IP route EIGRP 24 and 34. See, you will always configure route filtering like this. Access list number 10, permit 20.1.0.0, or you can find the summary address. Summary address is going to be 255.255.252.0, right? So I am only allowing these three subnets. Rest all are blocked, denied. And now router EIGRP as number 10, router EIGRP 10, distribute list number 10 direction in. On router number 2 also config T, access list number 10, permit 10.1.1.0, 0.0.255. I am only allowing the LAN of side 1, and router EIGRP as number 10, distribute list number 10 direction in. Now you can verify the routing table. See R1 routing table. So IP route EIGRP. What happened? So IP protocol. In access list number 10, we are blocking. Okay, so IP access list number 10. In access list number 10, guys, you can see first statement is deny. First statement is deny, right? So that's why it is denying everything. Say no access list number 10, and then access list number 10 permit 20.1.0.0 255.255.252.0, the summary address. Until then we can verify R2 routing table. So IP route EIGRP. Here you can see only 10 subnets are there. 12 and 13 was the unwanted, and we have filtered that. We have filtered those prefixes. On R1 also, so IP route EIGRP. Now you can see. So access list permit, sorry, no access list number 10, access list number 10 permit 20.1.0.0 255.255.252.0. So access list permit 0.0.0. Access list number 10 permit 20.1.0.0 255.255.252.0, and do so access list. This is the issue of simulation. Don't worry. Do say no to this, and access list number 10 permit 20.1.1.0 20.1.2.0 and 20.1.3.0. like this we can create. So IP access list. Now access list is fine. So IP route EIGRP. Wait for some time. So IP protocol. Okay. You can see for incoming update message we have apply the filtering, and now so IP route EIGRP. Now you can see only 20 submits are there, means 24 and 34 WAN link prefixes are now filtered. Getting my point? So we can apply the filtering on interface as well. Now guys, when ISP1 will advertise this submit to router number 1, what will be the source? Source message in update will be 12.2. When ISP2 will advertise, it is going to be 13.2 or 3, whatever IP address is configured on this interface. So let's say I want to filter prefix from source 12.1, then your extended ACL will not work. I want to filter prefixes from a particular neighbor, then you have to use extended ACL. In the extended ACL, we cannot match source and destination. Right? So for an example, if we have a requirement like this, that you need to filter route from a specific source, on a specific interface, you can filter the prefix with the help of extended ACL also, no problem. But from a source, particular source, you cannot filter it through extended ACL. Right? So in the extended ACL, we can define source as well as destination. So source will be what? Source is going to be your next hop. Source means next hop in the ACL, extended ACL. And destination means your prefix which you want to filter. Prefix. So let's suppose here, guys, in this scenario, even in this scenario, you can say, Praful, why we need extended ACL? We'll apply it on the interface. But suppose here I have one switch, guys. There is no direct link. There is no direct link between the router. Let's say router 1 is connected to one switch, and the switch is connected to ISP1, ISP2, and then we have remote site somewhere. So in this case, you can see on router number 1 we have only one interface, right? So here how you will filter the prefix from ISP1? You can't through extender, right? ACL. Here you know that when ISP1 is advertising the prefix, that time source is different. When ISP2 is advertising, then source is different, right? So in that case, extended ACL will be used. Clear? Clear, my dear friend?
Yes.
Yes or no?
Yes, sir.
Yes? Okay, great. Right. Now I am going to remove the filtering. First, say router EIGRP ES number 10. Router EIGRP ES number 10. No distribute list number 10 direction in. If you want to remove access list, you can say no access list number 10 also. And let me create one extended ACL now. Access list, let's say 101, and here I am saying deny host, deny IP host 12.1.1.2, which is ISP1 IP address. You can see this is the IP address of ISP1, right? And the destination is 20.1.2.0, wildcard mask 0.0.255. So this access control list is filtering this submit 20.1.2.0. Similarly, I can filter 3.0 also, 3.0, but it will filter from this source only, from 12.1 only, not from ISP number 2. From ISP2 all the prefixes will come. Let me apply this ACL, and before that let me allow rest all the traffic. Here I can say permit IP any. Permit IP any. Rest all the traffics are permit. Even in the same ACL you can deny these LAN prefixes also. Like sorry, these WAN prefixes also. Now router EIGRP as number 10, distribute list number 101 and direction in. Wait for EIGRP resynchronization. Done. Resynchronization is done. Now show IP route EIGRP. See guys, for the first subnet it is performing load balancing because it is receiving from both the ISP, but 20.1.2.0 and 3.0 are coming from ISP 2 only, right? Are coming from ISP 2 only. Next up is 13.2. So this is how you can filter prefix from any specific source. Clear? How we can filter the prefix from any particular source. Right? We are filtering the prefixes, some prefixes from ISP number 1. Right? Even with the help of route filtering we can perform path manipulation as well, guys. Like you can see earlier it was performing load balancing for all the subnet. Now it is not performing load balancing for lower 2 subnet. This is what kind of path manipulation. And this is the route filtering with the help of extended ACL and extended ACL. Now the third parameter can be used for route filtering is prefix list. Prefix list. What is the difference between ACL and prefix list? Now we can filter the route by using prefix list, but before that I want to know the difference between ACL and prefix list. Like you know the difference between extended ACL and extended ACL. In extended ACL we can only match the source, we cannot match the destination, or you can say we can only match the destination, we cannot match the source. In extended ACL we can match both, means we can block the traffic from any specific source. Now why we need prefix list? One minute guys. Yes, tell me the difference between ACL and prefix list. Okay, in the ACL how we are matching the subnet, how we are matching the prefix? With the subnet mask, network ID and subnet mask. You are matching network ID and subnet mask. That's it, so simple. And prefix list is used to match the prefix with prefix length. With the help of prefix length. For an example, I have some subnet here 10.1.1.0/24, 10.1.2.0/25, 10.1.3.0/26, 10.1.4.0/27, and 10.1.5.0/28. If I will ask you to filter prefixes whose prefix length is from 26 to 27, 26 to 27, right? If I will tell you match the prefix whose prefix length is, prefix length means CIDR value. If I will ask you match the prefix whose prefix length is /26 to 27, can you use ACL here? No. With the help of ACL, we cannot match the prefix with the help of prefix length. That's why we come up with prefix list. Prefix list allow you to match the prefix with the help of prefix length. Right? So for an example, guys, here on router number 2, now I have here slash value 25, CIDR value 26, then 20.1.4.0/27. Let's say 20.1.5.0/28, 28, and 20.1.6.0/29. And I am asking you to filter the prefix from the prefix length. Right? I am going to remove this filtering. Config T, router EIGRP, and this is the distribute list. Let's say no, exit, and even I can remove the ACL here. I can say no access list 101. Done. Now again my EIGRP neighbors will synchronize, you can see, and it will receive all the prefix. It will install all the prefix in routing table, you can see, and it is performing again now load balancing. On router number 2, I am going to modify the loopbacks. Interface loopback 2, IP address 20.1.2.1, 255.255.255.128 is going to be submit mask. Loopback 3, 3.1, and what will be the submit mask, guys? /26 192, then loopback 4, what will be submit mask /27 224, what will be submit mask /28
240.
240, what will be submit mask /29
48.
248, and the EIGRP network command 0 is already running, so go to router number 1 and show IP route EIGRP. You can see all the prefixes are coming and their prefix length is vary. Right here prefix length is 24, 25, 26, 27, 28, 29. And you have a requirement that you need to filter the prefixes whose prefix length is from 26 to 28, let's say. You need to filter the prefixes whose prefix length is from 26 to 28. Right? So here you can use the prefix list for your route filtering. In the prefix, in the access control list, always keep in mind, we have gap in the sequence number of 10. Sequence number of 10 means if I said access is number 10, permit this one, access is number 10, deny this one, right? So the first rule is going to be installed in the table with sequence number 10. Second rule will be installed with sequence number 20. There is increment of 10. Third rule is going to be installed with sequence number 30. And prefix list has gap of 5. Right? So if I am going to define two rules, let's say, in the prefix list. So first rule will get sequence number 5. Second rule will get sequence number 10. Third 15. Fourth 20, like this. Right? Here we have some characters like LE. LE means less than and equal to. Less than and equal to. Then we have G. G means greater than and equal to. and after that 0.0.0 means any. These are the components of prefix list which you need to keep in mind. LE less than and equal to, GE greater than and equal to, and 0.0.0 means any, right? So I can tell to my prefix list that 20.1.0.0 is my main prefix, /16 is my main prefix, and here I can say whose prefix length is less than and equal to 26, because I want to filter all the prefixes whose prefix length is from 26 to 28. So what I am saying, match the prefix from this subnet 20.1.0.0/16. All the prefixes are matching in this subnet, and then whose prefix length is equal to and greater than 26, sorry, less than and equal to 26 and greater than and equal to 28, right? Deny it or permit it, any action. So this prefix list is going to match 20.1.3.0, 4.0 and 5.0. These three prefixes will match over here in this prefix list. /value 26 to 28. Clear? Is it clear? This prefix list is going to match 20.1.3.0, 4.0 and 5.0, right? So for an example, what I do, let's say I want to filter all the prefixes whose prefix length is starting from 25, prefix length is starting from /25, let's say, to /28. I want to filter all the prefixes. What I can do, I can create one prefix list. Simply here command is IP prefix list, IP prefix list, and the name of your prefix list. Name of prefix list is, let's say, CCNP. You can define the any name here, and after that action you want to allow or deny the prefix. So I want to deny the prefix, so say deny. Which prefix you want to deny? 20.1.0.0/16, and then we can define the greater than CIDR value and less than CIDR value. Deny less than and equal to, I can say greater than and equal to 25 and less than and equal to 28, like this. This is my syntax. And implicit deny is there. If you will deny anything, it will deny all. So let me permit rest all the traffic. IP prefix list CCNP permit, what I told you, any means 0.0.0 means any subnet whose prefix length is, let's say, less than and equal to 32. Allow all the traffic whose prefix length is less than and equal to 32. And now if I will call this prefix list in the distribute list, router EIGRP 10 distribute list, and here I am going to call prefix list. Name of your prefix list is CCNP and then direction in, right? Wait for EIGRP resynchronization. Now you can see EIGRP resynchronization is done, and so IP dot EIGRP. So IP dot EIGRP. You can see, guys, /24 is there. After that /29 is there. 25, 6, 7, 8. Prefix with CIDR value /25, 6, 7 and 28 are filtered. Okay. This is your configuration. right? Now guys, let's say I want to filter all the prefixes, doesn't matter what is the prefix, 20, 10, 30, 40, any prefix with slash 24. If their CIDR value is 24, then filter it. Yes, you can do it very easily through prefix list. IP prefix list, again name CCNP and 0.0.0./0 means any prefix whose prefix length is greater than and equal to 24 and less than and equal to, sorry, action deny 0.0.0/0 whose prefix length is equal to and greater than 24, less than and equal to 24. That's it. And then IP prefix list CCNP permit, again any 0.0.0/0 less than equal to 32. Rest all are permit, right? So it is going to block all the prefixes whose prefix length is /24, right? You can verify it here. So IP prefix list. In the prefix list, you can see sequence number is 5 over here and sequence number is 10 over here, right? And now so IP route EIGRP. You can see 20.1.1.0/24 is filtered. 25 is there, 6, 7, 8. 25, 26, 27, 29 are there, but 24 are filtered. Means subnet over here, guys. WAN link subnet was there in the routing table earlier, but now it's filtered, right? On the WAN link, you will always configure /30, right? And I can filter all the WAN prefixes through single prefix list. Yes or no? Yes. Done. If it is clear, let me know so that I can move to route map now.
/30.
/30. Yeah, on the WAN link, you need only two IP address, one for router 1, one for ISP.
Yes, sir.
Right. So if you are using /24, that means you are wasting 254 IP addresses, 256 IP addresses are there total. Only 2 are in use. Rest all are not in use. So better to use /30 to avoid the wastage of IP address. In /30, we have only 2 IP addresses. And you should understand route filtering with the help of ACL and prefix list.
Yes.
Clear?
Yes.
Distribute list CCNP. Let me say no to this. Now guys, good. Now you know how we can filter the prefixes by matching the prefix, means network ID and subnet mask with the help of extended ACL and extended ACL. You also know how to filter the prefix with the help of prefix length. Now,
Yes.
so IP route EIGRP or so IP route only, let's say. See, there are some EIGRP prefix like 12, let's say 12.1. Not 12, 24. Right? What is the metric over here? This one. What is the metric for 34? This one only. For the WAN link, this is the metric. Guys, if I will ask you to filter the prefix whose metric is 30720, can you do it with the help of ACL or prefix list? Can you filter the prefix based on metric? You can filter the prefix based on network ID subnet mask or based on prefix length. That's it. You cannot filter prefixes on the basis of metric. Or while redistribution, we have seen the tag value. Can you filter the prefix with the help of tag value? No. Right? Then we come up with route map to filter the prefixes by checking these parameters. Right? On the router, if I am going to create one route map here, route map and the same name CCNP, let's say permit only and sequence number 10 match and put question mark. See how many things you can match over here. You can match the tag, you can match the source, means you can perform route filtering based on source protocol. Let's say multiple protocols are running, EIGRP here, EIGRP, RIP, OSPF, so many protocols are running, and you want to filter the prefix based on source protocol. I want to filter all the OSPF prefixes. You can do that. With the help of route type, we can perform filtering, right? In EIGRP, we have two types of route, internal route and external route. With the help of route map, we can perform route filtering based on route type. If it is external prefix, filter it. If it is internal prefix, filter it. You can also use the policy list, MPLS label. Maybe these are the new for you now. Just ignore it. Here you can see the metric. I can use metric value for route filtering. Local preference, you will learn about the local preference in BGP, length, IP address. We can also match the interface, community, ES path. These are the community, extended community. These are the part of BGP. In the BGP, we'll see these all attributes. ES path, community, extended community, local preference, weight. So the need of route map in the route filtering is to match the another parameter than the network ID, subnet mask and prefix length. If you have the requirement of route filtering based on network ID and subnet mask, you can use the ACL. If you need to match the source also from a specific source, if you need to filter any prefix, you can use extended ACL. If you have a requirement to filter the route based on prefix length, you can use prefix list. But if you have a requirement of route filtering with the help of metric, based on tag value, based on source protocol, based on these all parameters, then you have to use route map. Let me show you. Here you can see so IP route EIGRP or so IP route. In guys routing table, you can see this submit. Let's say 24.1.1.0. Metric is this one. Right? Metric of 20 submit is different. Metric of 24 and 34 is same. This one, right? So I want to filter the prefix based on this metric. It's so simple. Let's create one route map here. Route map CCNP name deny and sequence number 10. And here I am saying match metric. Match metric. Which metric? This metric. If this metric will match, then it will filter the prefix. Even here we can say match IP address, and I can call my access list here as well. No problem at all. Through route map, in the route map you can also call your ACL, access control list. But I am performing filtering for all the subnet, right? All the subnet. If you want to filter the prefixes based on metric and you have a certain range of prefixes, then you can use ACL as well. ACL to define the range of prefixes, like 20.0.0.0 means 20 subnet, and after that it will match the metric. It will then match two things, ACL and metric. If both will match, then only it will filter the prefix. It works on match all, right? Whatever matches you have configured under route map, if everything will match, then only it is going to take action. Match any means if any will match either metric or ACL, then it can take action. But your route map works on match all, right? So I'm not going to call ACL. I have just matched the metric. And now one more route map, route map, name again CCNP, and this time permit sequence number 10. If I am not matching anything, it means match all. And now if you will verify the route map, so route map, you can see here my route map name is CCNP, sequence number 10, action permit, and this route map is just matching the metric. Which metric? This one. Huh? Sorry, I did some mistake, guys, here. Let me say no to this, and let me call this route map on the same sequence number I permit. So let me permit with sequence number 20. Permit with sequence number 20. Could not find route map. Sorry. Route map CCNP permit sequence number 20. Right now. So route map. Now you can see we have one route map with name CCNP, and there are two rules. One with sequence number 10, another with sequence number 20. In 10 we are matching this metric, in 20 we are not matching anything, means match all. And sequence number 20 is allowing all the traffic, and 10 is denying those traffic who has this metric, who have this metric, right? And now let me call this route map under EIGRP, router EIGRP number 10, distribute list and route map. Name of route map CCNP, and direction I can say in. So IP route EIGRP. Now wait. Yes. Now you can see 24 and 34 submits are still there. So IP route EIGRP. Okay, so route map. Yes, you can see I don't have any prefix with this metric. Now if you are intelligent, if you know the routing protocol, you can understand it, how router is learning these prefixes. Now what is happening, guys? 24 subnet is running here, 34 subnet is running here. Now router 1 is learning 34 subnet via ISP1 and 24 subnet via ISP2, like this. Earlier ISP1 was advertising 24 subnet. There was list matrix, so that was the best, right? So I can also match this metric in my route map. I can also match this metric. Let me say no route map CCNP, and then route map CCNP deny sequence number 10, match metric, this one. And what was the metric here? This one. See here, if I am going to say match metric, this one, and do so route map. See here, it is matching two metric now. Exit, and then route map CCNP permit sequence number 20, higher sequence number. That's it. And wait for EIGRP resynchronization again. So IP route EIGRP. Now you can see the routing table, guys. 24 and 34 are filtered, right? Yes, it is filtered. So this time we have filtered the prefix based on metric. This time we have filtered the prefix based on metric. On the basis of metric, we are matching metric. clear? Tell me. Any question, guys? Till here? On order number 2, or let's say on order number 1, I am going to create one loopback. Loopback is already there, 10.1.1.0//24. Let me say router EIGRP as number 10. Sorry, no router EIGRP as number 10, then router EIGRP as number 10, and network 12.1.1.0 and network 13.1.1.0. So IP EIGRP interfaces. So EIGRP is only enabled on these two interfaces. On loopback interface, EIGRP is not enabled, right? And I can redistribute it in EIGRP. Router EIGRP is number 10, redistribute static. Redistribute static, and then you need to define the metric here. Metric means K values, K1, K2, K3, K4 and MTU. And after that, here I have one option of route map. Let me use route map here. Route map name is, let's say, ccie. So while redistribution, I use route map ccie, and route map ccie permit sequence number 10. Here I am setting one tag value. Tag, let's say 10. Tag value 10. I have created one route map. In that route map, I just set tag value 10 for all the prefixes. And I call that route map while redistributing the prefix in EIGRP. So now, IP EIGRP topology. In EIGRP topology table, you can find the 10 subnet 10.1.1.0, where it is. Are you able to find 10.1.1.0 in EIGRP topology table? So IP interface brief. So IP EIGRP topology. Not in table, let me take you to R2. So IP EIGRP topology. 10 subnet is not coming. Oh, we have redistributed the static subnet, guys. Sorry. Router EIGRPS number 10, that is connected network.
I mean,
Yes,
it's going on.
Redistribute connected, right? That is connected network, and metric and route map ccie. Now so IP EIGRP topology. Now see 10 subnet is there, and with 10 subnet tag value is also there. Tag is 10, right? So on router number 2, if you will check topology table, you can see we have one tag value with this prefix tag 10, right? Even I can say include and tag is 10. It will show me the prefixes whose tag value is 10. And on the basis of this tag also, I can perform now route filtering with the help of route map. When it is required, I will show you in the next class while advanced redistribution. While discussing advanced redistribution, I will show you when it is required. But now you can see the tag value, and with the help of this tag value also I can perform route filtering, because in route map I have option to match tag as well. 1 minute. Yes. Is it clear? In the roadmap, this time you need to run command match tag value, tag 10. That's it. Otherwise, all the configuration are exactly same. Okay. If anyone have any question, any doubt in this, please ask. Otherwise, topic for tomorrow is going to be advanced redistribution, which is the last topic of our routing EIGRP routing protocol. Then next protocol is going to be your OSPF, which is the most important routing protocol. So definitely we will learn OSPF in much details. Everything you have to learn very carefully in OSPF. OSPF is so important. Yes. It is
Sir,
tag.
when we filter /30, that time we will greater than equal to will to.
What?
Amit, how we will prefix list,
What?
how we'll
What
call.
slash
Amit,
30?
Means if suppose any WAN subnet is there, as you told, /30 we introduced, right?
Hmm?
If we want to filter that, so that time which command we will do?
Greater than equal to 30, less than equal to 30.
Okay.
When the tags and these all things are required, guys, let's say two companies are there, right? Company A, company B. In company B, there are two departments, sales department and HR department, right? And here through redistribution, you are learning these all prefixes in company A. How will differentiate the prefix? That which prefix belongs to sales departments, which prefix belongs to HR department. So we can perform tagging here. Tag is kind of label, right? For sales department, I can set tag 10. Here I can set tag 20, right? So if I need to check sales prefix in company A, let's say, so I can say so EIGRP topology table tag is 10, like that. And sometime you will have requirement to filter some prefixes on the basis of tag also, right? Now let's say your manager is going to tell you that do one thing. Now there is no one in the company who is going to communicate with sales department, or just one, I want to stop communication with sales department. So you know the prefixes which is coming from sales has tag number 10. You already know this, right? So it is going to be very easy for you to filter the prefix with tag value. In that kind of scenario, we are using this tag. Okay. Yeah. Tell me.